Welcome to Creating Complex Registry Discoveries. Now, a customer of ours recently asked for help with a discovery that they didn't know how to create. And when we investigated it, the solution was obvious. It was not obvious, but it was interesting. And we think other customers may find this approach to be useful. And while we won't have exactly the same requirements, I think the way we solve this information should be useful in other scenarios. So let's take a look at their scenario. Now, we're not going to share any customer specific information here. So I put together a similar scenario, but we filed all the serial numbers off of it. So the situation the customer had is in their registry, they had a registry hierarchy here, like we have this an example, level one, level two. And then underneath level two, they had multiple objects, and those are the things they want to discover. Now, the SCOM registry discovery is basically set up to discover a key or a value, but not multiples. So while we could discover object one, what we can't discover is both object one and object two at the same time with the built-in registry discovery. That's not a big problem. We're just going to have to use a script to do that, and we'll show you exactly how to do that. We are, however, still going to actually use a registry discovery. So what we're going to do is we're going to find all the machines on our SCOM network where this hierarchy exists. An example, level one, level two under HKLM software. The reason for this is that registry discoveries are really quite inexpensive. Script discoveries are more expensive. Not horrible. They've made significant improvements there. I don't want to scare anybody away from using script discoveries, but if we don't have to run a script discovery on some system, that's a better thing for all of us. So we'll use a registry discovery to find the machines that have this hierarchy, and then we'll target the script discovery only on those machines. So only where it's applicable will we run the script, and that's going to save some overhead, and it'll just make life a little easier. Now, this technique is a very common thing. It's called seeded discoveries, and you may find this to be very useful. In everything with SCOM, the idea is to target to the smallest group you can so that things only run where it's directly applicable. We could create a script discovery that would run on every machine and do the right thing, but it's better to use the really inexpensive registry discovery and then only run the slightly more expensive script discovery on those few systems where it's actually important. So we're going to create a new management pack here. So I'm in Management and MP Studio here. Just for what it's worth, I have a script there, a Word doc, text doc that I can just copy here, because if I copy and paste, if I try to type while I'm talking, it never goes well. So we're going to create this new management pack. We're going to store it in the store. We're going to target SCOM 2022, because that's what I'm going to deploy it to. We're going to create an empty management pack, and there we go. Now we want to create this Windows registry class. So we're going to do it from here. We're going to create the discovery and the class. We're going to create a new Windows registry class. This specifies the computer where we're going to look at the registry so that we can browse rather than have type things in. Now, we can choose other systems, but in this case, we'll just use this vMike Win 10, which is this local machine. From the registry entries page, we're going to browse. And as you can see, I've already been here today. This is the same registry hierarchy that we're looking at here. But in this case, it's in MP Studio, so we can select things. Now, the small trick here, we want to check to see if level 2 exists. And the way we do that is we select level 1 in the tree, and then we can select level 2 here in the entries and click Add. And now we're looking for level 2, which is a key in the 64-bit registry. So now we have our identification of the target. I'm not going to change the formal name here because we seldom are going to be using that, but I will change the display name so that we're very consistent with what we're doing here. Now our base class Windows local application is perfectly acceptable for this. Our discovery, we're going to change the display name there. Other than that, it's fine. Our target is Windows operating system, so this registry discovery will run on all SCOM monitored computers that are running the Windows operating system. Our expression is we're just looking for the existence of that key, and we're going to run this every day. Now, when SCOM imports a management pack, if a discovery is new, it'll run it immediately. And I'm going to put immediately in quotes. It can take a couple of minutes, but it's fairly quick. So we can just leave it as the daily schedule here. Now, I'm going to save this management pack and I'm going to deploy it to my management server right away. And the reason for that is a bit subtle, but I want these discoveries to run so you don't have to wait for it, okay? If we import this now, then that discovery is going to run in the next couple of minutes here. It depends on the size and how busy your SCOM environment is, but it should run shortly so that when we finished the script discovery, we'll be ready to run it and SCOM will know what systems to run that on. Otherwise, because we have two discoveries, one dependent on the other, if it doesn't work out that they're executed in the right order, it can take hours, up to a day, for the second discovery to run. You can change that with overrides, or we could change the frequency for the second one. But by deploying this early, it just helps get that out of the way. Now, just go down my crib sheet here. So the next thing is we need a script to do this. So let's look at the script I've put together. These first three lines of code are basically boilerplate, and they're going to be in all script discoveries. SCOM is going to pass in these three parameters: the source ID, the managed entity ID, and a computer name string. We're going to create this mom script API object, and from that we're going to create discovery data. This is a structure that that supports and encapsulates request to SCOM. So we're not actually creating these things. What we're doing is creating requests that SCOM will then evaluate and do the proper creation. It's a subtle thing, but it never hurts to have the pedantic discussion of this. So we're going to look in the registry. So we're going to set our location to the registry to HKLM software and example level 1 and level 2. That's the same place we were looking before. And we're going to get the child items there. And if you recall, our child items are object 1, object 2, and there's other things that we don't want. So we have this name parameter here. I hate trying to drag stuff in this Windows ISE. It moves things rather than just highlighting them sometimes. We're going to specify that the name has to start with object. So object star starts with object and has any characters after that. So this will match object 1 and object 2, but it won't match that other thing key. So we get this list of objects. Now, if there are none, that's what this if null test is, we're just going to exit immediately. So if it turns out that this is running on a system that doesn't have that hierarchy, we just quit. Now, for each of those objects, we're going to iterate over them one at a time. So the first time through, because objects has that list of object 1 and object 2, the first time through, this will be object 1, and the second time through, it'll be object 2. Get item on that is actually going to return this registry object that has the key and the values here. So that's the object. And from that, we're going to get that name value and the value here. And we're going to assign those to name and value variables. Now, this create class instance is going to ask SCOM to create an instance of this class, and it gives the name here. We're going to use this in the wizard, and the wizard will look at these scripts, and it'll look for create class instance. It'll look for that name, because the wizard, the MP, has to match the script. So we pull the name of your class out of the script to simplify things and make it a little more foolproof. Then we're going to add various properties to it. One of the properties we're going to have is principal name, and we'll just assign that to the computer name that was passed in here. This ties this object into an individual computer. This is a fairly common thing you'll see in a lot of discoveries. The next thing we're going to do is within our class that we're going to create, we're going to have two properties, name and value. And the wizard will look through this script and will find these add properties, and it'll look for properties in this class and create a name and value property so you don't have to type it in. But we just assign them the values of name, dollar name and dollar property, dollar value here. Now that we've filled in this class instance, we add it to the discovery data. And then we're going to iterate back. We're going to come through this for each loop again. We're going to give object is now going to be object 2. And we're going to do the same thing slightly different. Once we've finished all of our applicable objects, we're going to have this discovery data with the instances that have been added. And this line here simply returns that discovery data to SCOM. That's the end of the script. Once that's done, through a little bit of magic, SCOM will look at this data that we've requested, it'll validate it, and create these objects in SCOM. So it'll have this class definition. So within MP Studio here, we're going to create our next discovery. We're going to use create new Windows script class. We're going to browse and find our script here. There's our script body. You'll recognize all of that. And SCOM has already filled in, the wizard has already filled in the script parameters here. These are the boilerplate, and they're always going to be, they should always be right for you. So here you can see it's picked up the name and value parameters here. Now, the one thing I'm going to do is I'm going to make this name a key parameter so that we can have multiple instances of this class on a particular system. So for each system, we'll have multiple instances, but they're unique by the name. Then we have the name of our class. And again, I'm just going to not type that because that would be embarrassing for me, how bad I can type. Our base class is Windows Local Application. You may choose a different one there, but that's not a bad choice. We're going to have our discovery here. So we'll give that a better name. And now our target. And this is where it gets really interesting. Instead of running this discovery on all systems where Windows operating system exists, we're only going to run it on the systems where the Silent Demo Registry class exists, i.e. systems that were discovered by that first discovery where we know we have this correct registry hierarchy. And then we're going to set this up with a typical discovery of schedule of once a day. And we'll create that. Now at this point, we're going to just come back to our management server here, and we're going to look at, we're going to look at the target types. Now we haven't imported the second one yet. So here's our registry class, and it's already been discovered on this, vMike Win 10 on Select Demo path here. So let's go back here. We have completed our second discovery. We're going to save that MP. And as soon as it shows up in the tree here, I'm going to deploy that. Now, once that's deployed to SCOM, as I said, SCOM looks at the MP, it validates it, it distributes it to systems where it's applicable, which is going to be basically all the Windows computers because the first discovery is still in there. But then knowing the target for the second discovery, it'll also ensure that that discovery is distributed to the systems where it's applicable. And so in a few minutes, SCOM will have figured all that out, deployed that discovery to the applicable systems. Because it's a new discovery and hasn't run before, it'll run immediately. And I did that in big air quotes here because it can take several minutes. So while we're waiting for that, I'll just talk about a few of the other things we should do with a management pack once we've completed or we're working on it. We can verify it. Now, verify, make sure that the management pack is correct, basically at a syntactic level. It doesn't go deep into it. It just makes sure that it's going to be legal, not that it necessarily makes sense. These two warnings, unsealed management pack should not contain type definitions. It's just because we've got two class definitions in this unsealed management pack. This is not a problem. This is just a warning that Microsoft likes to put up. They'll do the same thing for relationship types. If you don't want to seal your management pack and you don't ever need to reference it, there is no need to worry about this. I generally always ignore this. Some of the other things we can do is we can check for missing display names. Now, all of the Select wizards will always create display names for everything, so that's not going to be a problem for you if you only deal with the wizards. Um, Having said that, there are two wizards that don't actually adhere to that. They use the templates that Microsoft provides for the database monitor and the website monitor, which does not necessarily fill in display names for everything. And that, unfortunately, is beyond our control. The other thing worth running or at least looking at is the best practices analyzer. This is sort of like the verify, but it goes to a much deeper level. It looks to see that things make sense. Now, it puts up a lot of stuff here, and all the text in green down here is stuff that passed. I don't care about the stuff that passed, honestly. If it passes, I'm happy. The only thing that didn't pass 100% here is management pack elements should have knowledge articles because I didn't create knowledge articles for the discoveries or the management pack itself. And so when we scroll down here, we can very quickly see the only thing that's in interesting color here is this orange for warnings for knowledge article for management for language code ENG and ENU is missing here. So nothing terribly serious. Now let's go over to our management server and see if perhaps we have our secondary instances created. So we have our script class. The class would exist almost immediately. And in fact, it did in the time we spent discover our objects. So here's our first object with that first object to be discovered value and our second object. And the path shows what computers those are on, etc. So we have gone through, we've done all we wanted to do. We've discovered these multiple objects through the registry. And at that point, we're complete. And so I'd like to thank you for watching. Have a good evening.